Hello students, Ms. Slyman here with your notes on 3.6. This one is about solving polynomials. We've already shown solving polynomials by factoring, but now we're going to look at what happens when we start with graphs. So in this first example, in this graph, I have nice pretty roots, and it's easy for me to see that my roots are -2, -1, and 3. So we've got three solutions, -2, -1, and 3. But what happens if we've got more than one solution and they're not integer or rational? Well, here I see nice roots of -2 and 1, but I also see two roots that are not nice. So if I wanted to find the exact solutions, well, I know that one of them is -2, one of them is +1, neither one is repeated. I can use my synthetic division on these two to help me factor this expression. You could also, knowing that x plus 2 and x minus 1 are factors, you could multiply those out and then do long division. But boy, synthetic division is so much nicer. So -2, 1, -1, -5, 3, 2, 1, -2, -3, 6, 1, -2, 1, -2, 0. And of course, because this is a root, my remainder should have been 0. I'm going to do another synthetic division. I'll switch colors for that one. Let's do it in green. So now I'm doing synthetic division just with this part. The reason I can do synthetic division again is because my remainder was 0. So 1, 1, 1, -2, -2, -1, -1, and my remainder is 0 as I expected. So that tells me that my function f of x factored into x plus 2 times x minus 1 times, from this, constant x squared, so x squared minus 2x minus 1. And now I know that this has real solutions. They're just not integers or rationals. So now I'm going to use quadratic formula because it says to find them exactly. So I'm not going to use polynomials. I'm going to use quadratic formula on my remaining part. So my roots, when this is equal to 0, I already know the -2, the +1, and now I've got -b over 2a, so +2 over 2 plus minus square root 4 minus -4, so that's going to be 8 over 2. I can simplify those. 1 plus or minus, this is 2 root 2 divided by 2, so root 2. So this one must be my 1 minus root 2. This one, my 1 plus root 2. If I wanted to, I could go back and check with polynomials on this equation. When I check with polynomials, though, I know that these are going to be decimals, so I'll have to look at the decimal equivalents. So those were examples 1 and 2, and I will be back.